This time in the workshop is a 1970s mixing desk. This is the HH Stereo 12. As its name suggests, this has got 12 channels, each featuring the usual EQ and gain controls. It's got twin analog VU meters and a blanking plate where the optional digital effects module fits. That's good news. However, because each channel's got 8 knobs and 1 slider, there's 108 knob caps to remove. Maybe. That's not good news. And it's not too ridiculous around the back. Just one input jack per channel, some output sockets, and sockets for those who know what they're doing, and a warning for me to keep out. Yes. And I don't know what this is for, nor do I want to get involved with it. Far too many pins. So let's connect this thing up and see what works and what doesn't. There's nothing happening yet. Although, it'd help if I turn these up, wouldn't it? And of course, all these are down low as well. In fact, every single knob's turned to minimum. That's not going to help, is it? Let's get the gain cranked up. Still no difference. Let's just do everything up halfway. Just give me something. These? Shouldn't think these would make a difference. Anything here? No. Nothing doing. Not a twitch from these either. Let's try channels 3 and 4. Let's turn all these knobs up again. Nothing on these either. 5 and 6. Still nothing at all. 7 and 8. Just going to save myself a bit of time here and turn all the knobs up. Got a little widget here for doing them in bulk. Very handy, if not a bit expensive. No. Still no. I've seen a pattern here. I'm sure these won't work either. As we thought. Nothing. How about the headphone socket? It did a little twitch. Still doing a little twitch. Well, the socket's a little bit dodgy. What about these? These are outputs after all. Still no dice. It helps if we consider the block diagram of the mixing desk. The 12 channels are all identical, and each has its own amplifier board and 4 outputs. On this mixing desk there's a left output, right output, echo and foldback, and each bus has got its own amplifier, with the left and right amplifiers having VU meters on. And given we didn't say any output from anywhere, the fault must be common to them all. And I'm thinking power supplies. Which is good, because I'm going to take all these knobs off. Some particularly short screws on this. And yikes, our first glance into the 70s technology. Well, this one's no virgin. Look, there's arrows. Someone's already been in here and graffitied it. And you can see there's literally bus bars on it, and you can see there's a bump in this one, so this module's been sort of bent. Well, I shouldn't laugh too much. Let's see what state they're in when I've finished. This thing's also covered in crumbly old foam. Ugh. And that part looks like it's been on fire, but I'm not sure how that could happen. Strange. It's also not encouraging to see a chip missing, so that won't work. It's quite clear to see a lot of them have been socketed. They've all been replaced in the past. But I think we've certainly got trouble on this board, mainly because it's the only other one in here. Yuck. Suppose it wouldn't hurt to check this fuse. It's dead. Well, we'll change it, but we'll proceed with caution. I'm sure it's not the only fault. So I've taken one of the bulbs out of the dim bulb circuit. So it's now throttled with a 60 watt light bulb in series. So it shouldn't pop this one even if there is a fault. Oh, look at that. Dim bulb's doing its job. There is a short. And the fault's just got worse. But where is it? Oh, it just popped, whatever it was. Can you hear it crackling? It smells a bit. I'm going to measure the supply rails anyway. Typically a mixing desk runs on plus or minus 15 volts. Let's put the ground probe on here. There's a 15 volt rail there. Yeah, that's present. Okay, we've got the minus 15 volt rail here. Also present. Okay, let's connect the outputs again. Oh dear, look at that. This thing's definitely got problems. Let's try input 1. Well, there's something. Oh. Let's see what's going on. Turn this down a bit. That's a bit more like a sine wave. Okay. Well, that meter needle's going mad. Let's see. Not having much effect. Oh. Ah. Interesting. I think I just need to increase the volts per division. That's better. So the right channel's noisy and the left channel's dead. I think I need to sort that out first, because that's going to play havoc with diagnosing the 12 input channels. So I think these knobs have to come off. Need a special tool to get these off, unless they're loose. Nope. It's called the stuffing tool, and I've modified it with that plastic insert so it sort of holds itself central on the potentiometer shaft. Makes it a lot easier to use. Apart from when they put the nut on upside down. That one will be loose, surely. And it is. These loose? Oh, no. Now, the board's free. Well, look at that. It's covered in this black rotten foam stuff. I don't know where this foam's coming from, but it's everywhere. I don't know if it's off the faders, maybe. This board's full of 741 op amps, very basic, and a few of these antiquated 739 dual op amps. And I've just noticed that every one of these actual caps, they're all 6.8 microfarads. What a weird size that is. I think I found the source of the ticking noise, a little bit of smoke I smell. This is a 741 op amp, I presume. It's got a 1 on the end, but it's definitely burnt up. Looking at the underside, it's not the first time this has been changed. Bit of a mess. Although I suspect it's a poor quality board, to be honest. I'll just desolder these 4 pins. But I need to be careful with this board. It's not in great shape. Pin 2 is connected to a track on the top, so I'll have to unsolder it from this side. There we go. Yes, this has definitely failed. Not only is it blistered at the top, the bottom's actually blown out of it. You see that big crack? Wow. No wonder it looks so manky under there. Need a bit of IPA. That's isopropyl alcohol. Not this Indian pale ale. I'm surprised how well that's cleaned up. Very nice. Let's pop the new one in. They're easy to come by, these things. The 741 is a very early op amp. I'm going to need a finer tip, so I'm going to change it. Which to choose? That one. Just pop this back there. Can't find the holes. There we go. Let's see if we got that channel back. Well, we've got a lot of noise on both of them now. It's a bit sticky, that one. I'm going to need another scope. Put the ground clip on this, pin 1. That's the 0 volts on the supply. Let's see how that signal is on the bus. Yeah, it's noisy on here too. Like pin 4. Yeah, same story. That means the noise is coming from one of these. or several of them. Let's try my precision probe. No. Bit of a rattle going on. Oh, oh, this one. This one's got a loose connection somewhere. Oh, it's this. Is it just that chip? Oh, it wasn't pushed in all the way. That was loose. That's rock solid now, look at that. Happy days. It's best to check the other outputs work before I move on. So that's the fold back and the echo. Oh, they're not working. Look at the scope. Let's just check the gains turned all the way up on these. So fold back is just outputting DC. Look at that. That's bad. And echo just very low amplitude. So we've got the echo bus, bit of crossover distortion there, but up to there, and the fold back bus. Oh, a lot of distortion. The waveforms don't look great, but they're not even coming out the other end. I'm more worried about that. We'll just zoom in on here a bit. Oh, yeah, the output's still distorted. Just very low on that one. The output circuit's quite simple. Comes from the bus, it's amplified by this operational amplifier here, through a capacitor, then we've got the gain adjustment knob, coupled through another capacitor into this op amp, which is just a buffer to give the sort of positive output, and it's inverted by this one to give the negative one. So this is your balanced output. It's going wrong somewhere in here. I've drawn the board layout here so I can get my head around how it all works. And the echo bus and fold back bus are both amplified by IC2. So we've got the grey wire for the fold back bus, there it is, and there's our echo bus. Okay, the output for the echo bus is on pin 1, that's definitely getting amplified. Fold back's on pin 13, also amplified. Let's just zoom out a little bit. Okay, it's clipped. This one, yeah, too much gain. And the fold back. So both signals have been amplified here, okay. See if it comes out the other side of this cap. Signal comes in here, and comes out here. Or not. What about this one? Signal comes in here, comes out here. Yes it does. Got a dodgy cap. Take that little nut off. That's the one. Out you come. Let's see just how bad it is. Let's measure its capacitance. It should be pretty bad, no signal coming through it at all. Test. Not sure how you can have a negative capacitance, but either way, it's a very small number. This will do, closest I've got, 10 microfarads this one. But I think in this application, as long as it's enough, it'll be fine. Well, that's a little different. Back to the non-existent fold back signal. We got it there, goes to this capacitor here, comes out there okay. There's a potentiometer here, so it comes out of this pin here, definitely still there. Then another cap, let's check it here, still got a signal there. This is actually connected as a buffer, so on here the output, we got nothing. Well, it's high. Let's check the power supply rails, minus 15 and plus 15. Yeah, that op amp's knackered. Another 741. Good job these things are cheap. Let's see how that works out. That looks promising. Let's knock that back as well. So these are working. Let's put these back in the outputs. Just remove this input signal. Pop in the echo return. Let's drop the volts per divisions a bit so we can see it better. That looks fine to me. Let's just check the controls out. Well, that works great. In the middle there. Now this. Well, a little jumpy there. Give that part a little clean, I think. Okay, now the auxiliary input. Signal's a bit low. Doesn't look too clever. What on earth's going on there? Is it the socket? No. I don't think so. Actually, that's starting to jump around quite a lot. We got noise again. Who's causing that? It's not channel 11 again, is it? No? No? 12? Oh. Channel 12. You little tinker. We'll keep it turned down for now. Concentrate on this other fault. Just plug that back in. It's somewhat distorted. The auxiliary input's wired to these terminals here. It's actually amplified by this chip here, this IC11. This is a fixed gain circuit and it's amplified, then fed back into the left and right output channels. So that's these pins here. We've got the cable on here. We can see it's got a black and red band. We'll just follow that back through the loom. Oh, and it should be connected to the auxiliary socket, of course, but it's not. What's going on here? Well, first I've just noticed they've actually soldered these two terminals together on there. And that's not been done anywhere else. Weird. And now we can see two separate wires on here. These are actually single cord screen cables. One for the hot and one for the cold connection. Weird. Where's that going? Oh, so this one, it goes to the blue wire eventually, because that's actually the echo send amplifier. What are they doing? So this wire, this is soldered to the third rail here, which is where the echo bus is. Oh, I see. So what they've done is wired the auxiliary input to go in series with the echo bus. Doesn't appear to work very well. I think I'm just going to undo this mod. It's a bit dodgy. Let's see if there's any wire inside here. Or if it's just a solder bridge, I don't know. Oh no, there is wire wraps all the way around it. It's disconnected now. It's a bit hard to touch, that is, Mark. We pull this tape off this cable. There's a lot of it. I'll be able to tell how old this mod is from how sticky this tape is. Not too many clues. But they've rather diabolically soldered it all together. I suppose it stops it. Just picking up spurious AC. I guess the best thing to do is just chop that little solder knot off. Need to bear a bit of this wire back. Slightly score it. And sort of separate these a bit. See how well wrapped they are. Just bare the ends off. I'm just going to tin the ends of the wires, keep them all together. Bit awkward to get at. Awkward shot. Just undo this one as well. Hopefully it just pulls off. Yes, it does. Where is it? Get this tape off here. That's not too bad. Just desolder them. I'm going to put more solder on this wire because it's got a tendency to run down it. So just get the iron on there, keep it hot, get this on, hopefully it's a stick. I can just cut this cable tie off. I think it's only actually holding this extra cable on. My cutters are in bad condition, look at that. Let's drop it again. See if it works now. Well, that looks better. See if we've got any noisy channels again. No. How about these? Very good. Okay, now for that echo return knob. Seems to be a bit dicky. Turn it down and then it comes back up. Yeah. Check it out. So that's it here. Just unsolder these pins. Of course this board's got no through hole plating, so I'm going to unsolder this pin separately. Oh. It's broken off. Well, I still need that leg anyway. You can see this broken leg's already got solder on it. Someone's already tried to solder it on. But you can see it's just not taken. Probably needs cleaning up first. Might take some of this solder off, there's a bit much on there. Solder with a screwdriver instead, keeps moving. Okay, there's some debris there. Let's establish if we can solder onto this. We should be able to. Yes. I think it's otherwise pretty clean. I'm going to put it back in. Takes a while to warm up all this copper. There we go. Perfect. So I'm pretty sure the main board's fixed, so I can concentrate on the channels. But every time I move this mixing desk, this crumbly foam keeps falling out. I don't know where it's coming from, but it's getting everywhere. If I give it a bang, it just rains out of this. One of my concerns is the input impedance select switches are all pretty open, and I don't want to get this powder sort of mixed up with any switch cleaner in there, turn it into a sludge. Might need to vacuum all this out. Just pull these out, if they will come out. Oh, there's lots of wires interconnecting these. Well, I'll try and do my best. And give them all the squirt of contact cleaner. And I can put that back in. And that switch. So I'm just adjusting all the settings for every channel to be exactly the same, so it's easier for me to compare how they're working. Just plug it into channel 1. Just going to set the output to be a square wave, so that's more useful for looking at the frequency response. So in the mid position we're getting more or less a square wave. We can increase the treble, it gets a bit more spiky on the leading edge. 2 kHz, similar effect. 600 Hz increases the whole amplitude, and the bass makes it slide the other way. So if I try channel 2, pretty similar. Channel 3, also pretty good. Channel 4, yeah, squarish. Channel 5, oh, that looks quite different. For these tone controls, oh, no treble. It looks like it's already got a lot of treble. It doesn't turn down. These aren't doing anything. Well, that's not right either. That shouldn't make any difference to the main output. Let's have a look. So channel 5, that's this one here. Oh, how embarrassing. This is the one with the chip that's missing. I'll soon fix that. The 739 dual op amp is somewhat obsolete. However, I've managed to acquire a few. I'm quite lucky these are socketed, to be fair. I'm hoping I don't have to take any of these modules out. It's a job I've done before, and it's very time consuming. Well, that looks a bit different. I wonder if that chip's a little bit different. I thought that's sort of generic. Let's check this out. I can take a 4739 out of the socket on channel 1, because we know that channel's working. Okay, that sort of confirms it. The UA739 is not quite the same. So what is the difference between the 4739 and the 739? Well, the UA739 is a dual op amp, and this is the pinout. What's interesting, it's got extra connections. These input lags, lag A, lag B, and we've got output lag A. Yeah, what is this about? Have a look at this diagram. These are basically for connecting external compensation components. Interesting. But if we look at the 4739, it tells you something here. The device is pin compatible with the UA739. However, compensation is internal. This permits a lower external parts count and simplified application. These are decades out of production, so the only place to buy them is places like eBay. However, I am not paying 25 quid for one. Plus postage. No. That'll explain why we've got missing components either side. So this was originally designed for the UA739 until they've changed to the 4739. So there's hope yet. Put the 4739 back in channel 1, back in its rightful place. But as this IC is to do with the tone controls, it's a little bit subjective as to how well it's performing. Because I don't actually know what value parts go in here, apart from it's a resistor and a capacitor in series. I'd rather mess around with the components on this one, because it's mainly just a preamplifier, and it's a lot easier to understand if it's doing its job right. So the 4739 is going into the tone controls, and the 739 goes in here. We can see the compensation components that are missing are here. They come out of pins 3 and 4, and they're in series. Let's go back on each other. And I have no idea the values, so I'm going to have to do some experimenting. And to help determine what the values are, I've got these two decade boxes. And this is a decade capacitance box, which allows me to dial in nearly 200 nanofarads. And this decade resistance box will allow me to dial in any resistance up to 100 kiloohms. So I'm just going to connect the cables to it, series these together. But then I need to connect these clips to pins 10 and 11. I'm just going to twiddle with the resistance and the capacitance value until I get the best amplitude and the best shaped square wave. We'll know when we see it. That's not making much difference at all. We'll go for the higher range. Not doing much. Try the resistance, knock that down. Oh, okay. Better. Okay. Oh, now that looks like it's overshot a bit. I wonder if the capacitance can help. No capacitance. Difficult to know what to say here. Definitely likes a little bit of capacitance on there. That's definitely helping. Let's try some resistance on here. Yeah, that's helping a bit as well. Is that 4K? Oh, we hit the magic number. Problem is you can't get a 700 ohm resistor, not easily. 680 is pretty close. Oh, that's no good. I'll dial it up to the 8. Still overshot a bit. I'll have to go the other way. 820 is the next one, and it's looking pretty good as a waveform. So we've got 820 ohms, 10 nanofarads. So we can just take these clips off and pop our components in. Here's the 820 ohm resistor. And the 10 nanofarad cap. Just solder these two at the top first. Bit of an awkward place. Upside down soldering, it's never brilliant. Just cut these off. Missed that one a bit. More upside down soldering. Try and get it to run that way. I think that's got it. Around here. And just snip them again. I just don't want to take any of these channels out. Nightmare. I'm now going to connect to pins 3 and 4. So we've still got the same old values dialed in here. See if we can make any changes. Nothing's doing there. What about the capacitor? Remember, this one is a physically bigger capacitor, so stands a chance it might be a bigger one. To be fair, anything I change seems to make it slightly worse. Oh, is that capacitor related? It clearly needs a bit of damping on there. We've got 680 ohms, that's a standard value. 20 nanofarads, that's not standard. 22, seems to be okay. We'll go with that. I think it's about as good as I'm going to get it. This is guesswork really. Now I can just pull these off, put the components in. These are all 22 nanofarads, so I need to find one that will fit the pin out. Oh, that's the right size, I reckon. Bit overkill, 400 volts. That's in. And the capacitor. Oh, made for the job. And solder the pins at the top again. Snip that off. Let's get under there. We'll just cut that little bit off. Sort of blends in, apart from the red thing. Okay, power that on. Yes, slightly off adjustments, get it square again, or that back, or maybe just more bass. Either way, it's not a million miles off. So that's channel 5 fixed. Channel 6. Yep, that'll do. Channel 7. Yeah. Channel 8. It's a bit low. We got a loose connection. Wouldn't surprise me if it's on this gain pot. Yeah, it looks a little bit wobbly to me. We'll just solder it anyway. Actually, we'll do all this row. They all look a bit ropey. Well, that looks better. Let's check the rattle test. Yes, rock solid. That's okay. We'll do channel 9. That looks good. Channel 10. That's about right. 11. Oh no. What's going on there? Yeah, it's a switch. Let's get a bit more switch cleaner. See if that gets it going before I have to just completely dismantle it. Seems to have done it. And finally, input number 12. Oh, is that a dicky switch as well? No. I'm going to put a second input into channel 11 so I can compare them. Same signal. We'll check the preamp output, pin 1. Okay, what's a good channel look like? The same. So pin 13 is the tone control buffer. That looks okay. What about up here? The bad channel. Oh, off the screen. What does that mean? So pin 13 comes from here. Follows across to a resistor. This is just feedback from that pin there. That's okay. Pull that trace across. It goes to this component here. That's capacitor. So on this side we see the input signal. Go the other side of it, if I can. Oh, there we are. That should be the same as this side, really. I think we found our culprit. Just grab the end with the tweezers. And get the iron underneath, just lift it up. And the other one. See if I can get the desoldering tool in there. And it won't reach Boppy, but it might have enough power. In with the new one. 10 mics again. I haven't got any 6.8 mics. Don't need this signaling, it's going to confuse things. Well, that's a massive difference. I think we found it. So we can get our square wave out of it, a bit more bass. Yes, perfect. They could probably really get this nice. Nice job. So the faults are fixed, just got to put it back together. I have a feeling it's not going to be that straightforward. Although before I do that, I better check the headphone output. I haven't tested it. Take these mono test leads out. Plug this stereo one in. Well, look at that. Beautiful. Volume control on here. Yeah. And this one. Yeah. Can't moan at that. I'll put these lock nuts back on here. Got to get the threads right on it. Just torque them up with the tool. One of the problems I've got with this base, it's been re-powder coated. A nice new shiny fittings on here, it looks great. But they've got the powder coating inside the threads, so the screws don't go in very well. And the screws, they're not metric either, I think they're an imperial screw. I'm guessing these are 2BA. So I'm just going to run a tap through them. Now the screw fits. That's better. Let's get the cover on. So there it is, back to its former 70s glory. Incredible how just a few components can cause so much trouble. So a little bit of 70s nostalgia, a little bit before my time I'm afraid, but it looks like the fuse blew originally because it had a dodgy shorted op amp that blew itself to pieces, so that was what that was. But at least I didn't have to strip down all these channels. There's something. Catch you next time.